Okay, so technically this is video 3 from section 6.2. Really, it should have been video 2. I made a like a 2-minute video explaining. I wanted you to write that one thing down. And so sorry, it's not frozen. I'm just thinking here for a second. Now, why don't I just go back to it? So actually, I'll probably just get rid of that video in between, so this might not make any sense because I'm not even going to put this video up. So let's write this down. Yeah, this was pretty much the only thing I did in the second video, so we'll call this video 2. So write this down and we'll put this all together here. All right, so pause it if you need to, but let me read what it says. It says, to anti-differentiate using substitution, let u equal an expression such that when you take the derivative of the expression, you will get something similar to another expression in the function. Alright, now the reason we do this, okay, so pause there if you need to. I'm going to scroll down here. I'm going to keep going with it. Keep this video shorter. So the reason we do this is so we can substitute du as well. Okay? That's why. Alright, we're going to try to substitute in for du. Obviously we're going to substitute for u. We're going to plug u in for something. And we're also going to substitute du also. And that's going to help us out. So essentially what we're trying to do is this. We're trying to take the integral of f of x dx and rewrite it as the integral of f of u du to make integration easier. Okay? Trying to make it as easy as possible. So if we have a bunch of junk in our function, we're going to try to substitute so it becomes a lot easier. Okay. So let's go ahead and I'm going to flip over to the next example. See where that gets me. So here we go. So every time you do a substitute, this one is going to be a substitution property because it looks like we've got a composition of 2 functions here. Actually, we've got a composition of multiple functions. We've got x squared here, we've got the square root of something, and we've got 5 plus 2x cubed. Okay. So what you need to think, and I'm going to put little thought bubbles here. This is what you should be thinking. Alright, I'm going to make my bubble kind of big. Alright, so you need to change. Right now we have a function f of x. It's a function with respect to x. And we're integrating with respect to x. I want to change that and get it to look like the integral of f of u du. Now remember, f of u du. Okay. So, that right there is what we're trying to do here. Okay, so we need to cleverly pick our u. Now, this is something that just takes a little bit of practice. We want to let u equal something that if you take the derivative of it, something you can easily take the derivative of. Okay, that if you do take the derivative of it, it gives you something similar to what we have already. So let me explain here. So actually, let me just go ahead and tell you what I'm going to let u equal. Again, we're kind of new at this. I'm just going to help you through it here. So this right here is what I'm going to let u equal, whatever's under the square root. Okay? The reason for that, I'll kind of explain it as I go through. So let me let u equal 2x cubed plus 5. The reason I'm going to let this happen, because if you think about this, let's go ahead and take the derivative of it. But if I do take the derivative of this guy, so du over dx, isn't the derivative of u the same thing as du over dx? Okay? That's going to equal 6x squared, and then what is the derivative of 5? Well, it's 0. Okay? So really, it's just 6x squared. So guys, look at this. We've got 6x squared, but up here in the function, we have x squared. So that's why I said we want to make it something similar to another expression we have in the function. So it's not exact, but that's pretty close. I mean, we've got a constant times x squared instead of just x squared. Well, I'm going to show you how to take care of that constant, all right, in a second. But that's why I let my u equal to what's underneath there. Okay, so let's keep it moving, guys. So this is kind of a... So before I move on, though, what we did in the last example was we tried to solve for du, and there's a reason for that, and I'll try to explain that as we move on as well. So what if we wanted to solve for du? Well, we want to get rid of division by dx, so I need to multiply by dx. Those will cancel, and so we're left with du is going to equal 6x squared dx. Okay, so now let's get back into the nitty-gritty here. Let's get back into the integral. All right, so I'm going to rewrite the integral again. Do this in blue. So it's the integral, I'm just going to rewrite it, x squared times the square root of 5 plus 2x cubed, and then dx. We want to try to write this as the integral of f of u du. Right now it's the variable's x, and we want to integrate with respect to x. So here we go. So this is the same thing. So what I'm going to do is I'm going to go ahead and try to substitute my u in. So didn't we say u is equal to 5 plus 2x cubed? So we can rewrite this as x squared times the square root of u, but we still have this dx. Okay, we haven't done anything with that. We will eventually. We haven't yet. Okay. So, again, I'm trying to set this up for you so it's very easy to see here, but I'm going to use a little commutative property, a little associative property here. So here we go. This is the same thing, agree or disagree, as the square root of u times x squared dx. Hopefully you guys agree, because that's true. You can just multiply in any order you want. It's multiplication. All right. Now guys, it would be nice, so right now we have an expression with u in it, but it would be nice if we could somehow make this, if I can make that look like du. Now it doesn't look exactly like du yet, okay? But if I can make that equal to 6x squared dx, then I can just replace it with du. Right now it's just x squared dx. So watch what I'm going to do here. Now I'm not going to break any rules here, any laws of algebra or integrals or anything like that. But I'm going to put the 6 right there in front of it. Now that might not make sense right now. Let me explain why I'm going to do that. Well, I can't just put it there. That's going to change the value. I've got to do something to counteract that. So guys, if I put the 6 right in front of the x squared, okay, what I have to do to counteract it is to multiply by 1/6 at the same time. So guys, think about that. If we multiply by 6, yes, that changes the value. But then if we turn around and multiply again by 1/6, well, what is 1/6 times 6? The answer is 1. Guys, I can multiply all day by 1. I can multiply by 1 as many times as I want. So that's what we're going to do, guys. Multiply by 1/6 and 6 at the same time. So the reason I did that is to make this look like du. So now what I can do is I can replace that whole thing with, hang on, my bad. Isn't du equal to that? Okay. So I wanted it to look like 6x squared dx. So now I can just, so now I can just replace it with du. All right. This is going to be du. All right, so let me rewrite that. So it's going to be 1/6 times the integral of the square root of u du. All right, now it's easy from here, guys. We should be able to do this. We've done antiderivatives. This is the square root of u is the same thing as u to the 1/2, isn't it? And what is our rule? What do we always do when we have a power function? Okay, if we want to integrate this guy, when we have a power function, we need to add 1 to the exponent. Now think about this. When I add 1, okay, that's the same thing as adding 2 over 2. So what's 1/2 plus 2 over 2? And the answer is 3 over 2. And then we always divide by the new exponent. Okay? So the new exponent is 3/2, so I need to divide by 3/2. All right? And then the du goes away, we're just left with plus c. Because we now have integrated with respect to u. Okay. Hopefully you're still with me. So let's just keep it going. Now, instead of dividing by a fraction, we could always multiply by the, reciprocal. So it's going to be 2/3 u to the 3/2 plus c. Now, I'm going to distribute here. Well, you can kind of distribute. You don't really have to because, guys, if I take I don't know what this constant is. If I take 1/6 times a constant, I've still got a constant. So I'm still going to write as plus c. So this would be, when I multiply fractions here, it would be 2 over, guys, it's going to be 2 over 18. So isn't that 1 over 9? Hopefully you follow that. 1 times 2 is 2. 6 times 3 is 18. 2 divided by 18 is 1/9. So it's going to be 1/9 u to the 3/2 plus c. And now at the end, when I've got everything, I'm going to plug in what we let u equal to. All right, so here we go. It's going to be 1/9 times, I think we let u equal 5 plus 2x cubed to the 3/2 plus c. So that right there is going to be my answer. You don't have to worry about distributing the 1/9 because of that 3/2 power. We can't distribute inside there. Okay? So that is it, guys. That is our answer. But I'm going to keep going. I'm going to show you why this works, why this is true. Or not really why. I mean, just we're going to check our answer. Okay? So if we want to check our answer, we just found that that's the antiderivative, didn't we? So if I want to check to make sure I got it right, I could find the derivative. Okay, so if I take the derivative of that, shouldn't it give me this? All right, let's go with it. So let's do it. I'm going to take the derivative of that guy. Now, hopefully you guys see, this is going to require chain rule. Okay, it's going to require chain rule. So I need to multiply, hang on a second, I need to take the derivative of the outside function, leaving the inside function alone right away, and then multiply by the derivative of the inside function. Okay, so here we go. So let's take the derivative of the outside function. All right, so the outside function is just something to the 3/2 power. Okay, so remember when we take the derivative, you bring it down and you multiply it, and then subtract 1 from your exponent. Okay, so we're going to bring it down. So guys, hopefully you're all right with this. 3/2 times 1/9, I'm going to go and multiply these. It's going to be 3/18, which is 1/6. Okay? So I'm bringing that down, multiplying. So again, let me verbally say that. Again, one more time. Of course I'm going to verbally say it, but yeah, 3/2 times 1/9. 3 times 1 is 3. 2 times 9 is 18. So we got 3/18. That reduces to 1/6. Then we leave the inside function alone right away. We subtract 1 from that exponent, so it's going to be 1/2 power. Okay, 3/2 minus 2/2, or 2/2, is 1/2. And then we need to multiply by the derivative of the inside function. So what is the derivative of 2x cubed? Well, plus 5. But the derivative of a constant, 0. So what's the derivative of 2x cubed? The answer is 6x. And what's the derivative of this constant? Yeah, you guessed it, 0. So guys, look what we got. This is pretty simple. You don't distribute this, because again, we have it to the 1/2 power. Sorry, I messed something up, and I would notice that in the next step. It's not just 6x, it's 6x squared. Okay. Made a mistake there, make that change. And then 1/6 times 6x squared, I almost did it again. 1/6 times 6x squared is going to be x squared. Is this starting to look familiar? It should. What's anything to the 1/2 power? How can I write that as a radical? You got it, square root. And I messed up, come on. This is cubed, this should be cubed, and this should be cubed. Yep. That right there, well, I'm not going to circle it, but that's our original. That's what we started with. Hopefully that makes sense. All right, that was kind of a long example. I'm going to wrap up this video right here. If you need to, rewatch it, but hopefully that's okay.